Good morning. I think still we have around 1 minute. I will wait for 1 minute and after that I start the lectures, today lecture. Uh, Meanwhile, any of you who has question regarding the last lecture, that today again we will repeat some part, and especially I will going to describe the critical point regarding the last lectures again and do some example. Please inform me. Today was your last day for the. Today is your last day for the task number 3. I wish that you solve it, and then I will put the solution for the task number 3 soon. We change this time because I feel that maybe we should have the less net problem in this time. Anyway, still, I think that using the webcam with this software will affect the performance of the application. Then I request you that please turn it off, turn your webcam off and your sound off. After that, we can talk, and even we can have the talk in private in WeChat. Okay. Uh, Last time, uh, we have the help from Roy that he helped me. Then we put two previous lectures on YouTube as well as mock system. I put in these two different systems because I thought that in mock system maybe it's become busy, and YouTube will have the sometimes better performance. Then you can take it from both system or both route that I tell you, and there is no difference between the lecture which I download on mock system or download on the YouTube system. Okay, let us start the today lecture. Don't waste time on that. What I'm going to tell you today is from the binary arithmetic addition and subtraction of the binary numbers, and we will talk regarding the carry flag and overflow flag in binary arithmetic. It's not difficult part, but it's related to the previous lectures that we have. Uh, Anyway, in the binary addition, last time I tell you that we have one uh, rule or one similar table like this, that based on this table we can have the pattern or we can have the root to do the arithmetic job. First thing is that addition is that it's okay for the binary subtraction, multiplication, and division, and there are four rules for binary addition, as you can see here. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 0. Just the difference is here. 1 plus 1 will have the sum of the 0 and carry of 1. The just difference between the uh, our routine arithmetic job means that addition part, and the binary part is this part that you can see here. For the binary subtraction also, we have some rules. Something like this, that 0 minus 0 is 0, 1 minus 0 is 1, and 1 minus 1 is 0. Okay, till this time we are okay. And 0 minus 1, it's 0, 1. We have one concept that we call it for the subtraction, we call it borrow. And we have one concept which we call it as the carry in the addition section. By the way, you can see that most of the things is very similar to the routine subtraction that we have in our uh, routine subtraction and addition. Just this 0 minus 1 is different, which we have subtraction and borrow. Okay, but let us speak more deep regarding the two new things that we showed. One was carry flag. Actually, the rules for turning on the carry flag in the binary or integer match are two. First is that the carry flag is set if addition of two number causes the carry out of the most significant or leftmost bit at. Means that it's something like that. You are limited to the 4 bit, and if any of arithmetic job will going to have one additional bit, okay, suppose we are we restricted up to the 4 bit as I show here, uh, and then if one after the addition something happened which is more than these 4 bits going to show, that part we call it carry. As you see, suppose here I restricted up to the 4, but the real one is last. As you see, 1 plus 0, it's become 1 0. Then this one number will go for the next part. Then on the other sides, the carry also sometimes the which we call it in borrow in the subtraction part. Flag is also set if the subtraction of two numbers require the borrow into the most significant or leftmost part, which will be subtracted. You can see in the below example that I show you. For the last bit, again, we have the problem for the bit, which we don't know what we should do with that because it's out of the capacity. It's something like that. Your car needs to have the some uh, specify amount of petrol, and now your uh, space is full. Then you cannot put more what we can say. You cannot put more petrol on that. Okay, and then have these two rules to having the carry, and in the other case, which anything will happen more than this, the carry flag will turn to the 0. Something like this example that I show you: 0 1 1 1 plus 0 0 1, which is equal to 1 0 0, which is carry flag is turned off, and 1 0 0 minus 0 0 0 1, which the carry flag is turned off again 0. In unsigned arithmetic, we can watch the carry flag to detect the error, and in signed arithmetic, the carry flags tell you nothing, which is interesting. Then, in the other way, we can say this carry flag is something like error detection part for us, and which can show us the arithmetic job is correct or wrong. Well, and let us see what is overflow flag. Again, we have two rules for turning the overflow flag in the binary or integer uh, math. We have two rules. If sum of two numbers with the sign bits of yields a result number with the sign bits on, the overflow flag is turned on. See the example that I show here: 0 1 0 0 plus 0 1 0 0. The overflow flag will turn on, as you see here for the last bit, the overflow we have. And if sum of two numbers with the sign bits on yield the result number with the sign bits off, the overflow flag is again turned off, turn on. In any other case like this, the overflow flag should turn off. Suppose, see the example of 0 1 0 0 plus 0 0 0 1. You will see the answer which overflow is turned off, and some other example which I show here for you. Note that you only need to look at the sign bit, means that the least most bit or MSB part of three number to decide if the overflow flag is turned on or off. If you are doing two's complement, which we are going to do it today. Overflow flag on means the answer is wrong, and you add two positive number and got the negative, or you add two negative numbers and got the positive. If you are doing the unsigned arithmetic, then the overflow flag means nothing and should be ignored. Then we can have one rule for the students that they are uh, wants to have one straightforward rule for today lecture is that this overflow and this carry is has the meaning when we are doing the with the signed arithmetic job. The rules for two's complement is the rule which can detect error by examining the sign of the result, and a negative and positive added together cannot be wrong because the sum is between the addends. Since both of the addends fit within the allowable range of numbers and their sum is between them, it must fit as well. Mix sign addition never turns on the overflow flag. Uh, Overflow flag. And in sign arithmetic, we can watch the overflow flag to detect the error. In unsigned arithmetic, the overflow flags will tell us nothing. Then just have these two golden rule, which I show here, that overflow has the meaning when we are speaking regarding the signed or unsigned arithmetic job. Okay, well, let us do this example. In this example, I'm going to do the subtraction between number 26 and 12 into the decimal base. As you see here, 0 minus 0 is 0, 1 minus 0 is uh, 1, 0 minus 1 I cannot do. I should borrow from the last part. Then 1 plus 1, it's as shown here. Then again, I should take borrow from another part and another part, and like that. And after the completion, as I know that in the decimal section, we know the answer is 1 4. Then if we convert the binary 1 to the decimal also, we can see that the answer is 1 4 again. Same if I want to do the addition between the two mentioned number which I have here, you will see that the result is 36. Because last lecture we talked regarding this subtraction and addition, I want that all of you check this slide and then learn it better, because really it's just regarding the two previous table that we review uh, initial of this lecture, and also I tell you last lecture again. Okay, can we do much more arithmetic job, and what will remain? The remain part can be the binary multiplication between the numbers. It also have some rule. Just for 1 minute, 2 minutes, see this table. It's quite similar to the real multiplication that we will do. Means that 0 multiplied by any number, answer is 0. It's like that. And 1 multiplied by 1 is just 1. Then we should not have problem with multiplication of the binary system. Okay, then the binary multiplication is very similar to the decimal multiplication, as I already noticed you. And it's simpler than decimal multiplication because only zeros and ones are involved with our job. There are four rules as we show into the table, and it's nothing to remember because they teach you when you were in elementary school. But how we can show it? I bring one example. It's interesting to note that the binary multiplication is the sequence of shift and adds the first term, depending on the bits in the second term. Suppose if I have 1101 and wants to do the multiplication between 1011, then we will see that first one will multiply to all digit. Okay, then the number is this. After that, we will put 10, and then we will do the next one. It means that the next one will multiply to all digit. Then this number will come. Then again, because we are going to do the third round of our job, we have 30, and then uh, for the 30, because next part is 0, then everything becomes 0 0. Here one step is remain, which is 0 0 0 0, and last one is this. How many numbers I have before that? 1 2 3. Then I have 30 here, and again I have 1 1. Then I should do the addition for all. Hmm? Same job we will do when we were in elementary school, and they teach us the um, addition and subtraction. Uh, you will see that 1 plus 0 0 is 1, 0 1 0 is 1, 1 0 0 is again 1, 1 plus 1 plus 1 is 1 1, then 1 1 again will go here as the carry. Then we have the 1 plus 1, which is become 1 0. Again, I have 1 here. 1 plus 1 is 1 0 again here. And last part is 1 0, which uh, um, it's addition of the 1 plus 1. Okay. Then what we find that the multiplication is not difficult. Do one more example. Suppose I want to do the multiplication of 26 into 12 in the decimal. Okay. First is very simple. I just do the 0 will be multiplied to all digits. As we say, everything becomes 0. Next part is that I will go shift one step here, means that 10 is here. And then again, I have the 0 to all. Next again is 0. Next is 1, sorry, here. I will put two place for the 0, and then do the multiplication for our number. Then I have three parts, and uh, go on. We will continue for that. Then after that, we will do the summation for all the parts, and simply we will find that the answer will come up. Then you will see that multiplication is not difficult with the numbers. Just I give you 2 minutes. You can 1 minute, 2 minutes to review what I tell you. Maybe you can do it with piece of paper in front of your hand. Just have a look at that. Well, you will see it's not difficult. Uh, you can do it very simply. Okay. What will remain? Remain is binary division, which is similar to decimal division. It's called as long as division procedure, as you will see here. Suppose if I want to do the division between the numbers between two numbers that I show there, what we should do, and as I show here, um it's the division between the uh, process of two number. Suppose I wanted to divide 7 in decimal and 42 in the decimal again, and I show the process here. But mainly we are not much more concerned regarding the division of the binary in our series of lectures. Just I wanted to show you that we have also division in the binary system. Even your book is not much more discuss regarding division part. Then division part you can put aside. Even multiplication you can put aside. Because multiplication is nothing by the addition part. Mainly, I want that you learn much more regarding the addition and subtraction. Let us do this example now. Please take one piece of paper and note down these two numbers. Suppose I want to do the subtraction between 110 and 101. Okay, please have a paper. Okay, if you can see here, first part is 0 minus 1. I should take the borrow. It's should become 1, and I should cut and take the value from the next part, and that part should become 0. Then 1 minus 1 is 1. Next part is 0. Now it's become 0. 0 minus 0 is 0. And 1 minus 1 is 0, 0, 1. Then we will see that the answer is 1. If we want to compare and even test that the same result is on the decimal, it's very simple here to know, because now the value of this number is something like this is 1, this is 2, and this is 4. Then my number in decimal is near to 6, not near, exact 6. And this one is again 5. Then what I have done, I just do the subtraction between 6 and 5, which is obviously I know the answer is 1. Okay, if we want to have more practice, something like this, 11000, and I want to subtract it between 111, what should I do? It's also very simple. I can do the borrow from the last part, then first one, it's become 1 minus 1, and then we can do it. These examples you can take from the PPTs because it's very similar, and we can go ahead with this example. Now, please do this. If we want to uh, do the subtraction between 101 and 1001, like that, what should we do? We want to do the subtraction. See, 1 minus 1 is 0. 0 minus 0 is 0. Then this can be 0 and this one can be 1. Huh? Then it's become 1. Same, if I have 1000 and I want to subtract it from 111, it's become 001. Uh, Same job we can do with this example. I think it's better that you also solve all the example of this PPT with your hand today. And if you have question, then we can talk and speak regarding that. Okay, that was something like manual arithmetic job. But what is our main aim? Our main aim is not subtracting, but using the first complement or second complement that I'm going to tell you now. If I want to use the first complement, we can subtract two binary numbers and using that. The step is that to write the first complement of the subtracted and to add this with the denoted number. If the result of addition has the carry over, then it's dropped and 1 is added in the last bit. If there is no carryover, then first complement of result of addition is obtained to get the final result. uh, and it's this number is negative. See one example. Suppose I want to do the subtraction between 110101 minus by the 1001001. Okay, what should we do? First of all, we should take the first complement of the number. Okay, what was the rule for the first complement? First complement was that whatever one I have, I should convert to the zero, and whatever zero I have, I should convert to the uh, one. C means that we will remain the first number and then do the first complement for the second one. If I want to convert this to the first complement, it's become 0, 1, 1, 0, 1, 0, which I show it here for you. Okay, and then I should do the addition between this number and first number that I have. Let us do 1 plus 1, 0 is 1. 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 1 is 1. 1 plus 1 is 1, 0. Huh? And then you will see that I have carry over. Then if I have the carry over, again I should do add it with 1. Means that after finishing the subtraction, I will add it with 1, and their required difference is something like this. If you convert this binary number into the decimal, you will see that the um, job that we have done was correct. Okay. Again, another example we have here, that is 101011, which we are going to do it with the first complement of the second number here. And here you will see that after adding that, we don't have any carry, which it means that the numbers is 0. Okay. One more job. One more job. What if I have the flute number? How I can do? No different. Simply, again, we will take the first complement of the second number, then do the addition. If we have the carryover, then again we will add it with 1, and then the answer or subtraction will come out as I show here for you. Um, what will happen if we have the 8 bits of one's complement addition? Let's suppose we have the number of A8 in 16 and Y as the 86 in 16 base. Okay. What will happen if we want to do this addition? It's something that we have done. Suppose if we take the number X as this much and y and x as this much, then first complement of the number is of x is something like this. It's simply we can do this. PPT or this example is mixed from some different number, and just I want to show you that we have the same process for that. Then first complement is nothing. If I want to do the subtraction, just I will take the first complements of the second number, do the addition. If I had any carry, I will add it with 1. If I didn't have any carry, it means that my result is negative. Now, what will happen if I want to do the subtraction by 2's complement? Okay, 2's complement. As last lecture also we talked, with the help of subtraction of 2's complement, we can easily subtract two binary number. The process is that first we will take the 2's complement of second number, then we will add it, and if final carry uh, we have some carry, it's dropped and result is positive. And if there is no carry, the two's complement of the sum will be results and it's negative. Okay, let us see these rules in the example. Uh, Suppose I have the number 110, and I want to subtract it by 10110. The number of bits in the subtracted is 5. That will be noted is 6. And we make the number of bits in the subtrahend equal to that of minuted by taking zeros in the 16th place of the subtrahend. Now, two's complement of number 0110 is something like that. As you remember, the rule for the two's complement was that first we will take the first complement, then we will add it with 1, then it's become two's complement. Similarly, if you have this job, or simply if you do this job, you will see here that after addition of that, I have one carryover, and after dropping the carryover, we will get the result of subtraction of these number. Let us see one more example, which I want to do the subtraction with the help of two's complement, and my number is 10110. I want to minus with the 11010, and you will see that first I will take the two's complement of the second number, then I will add. It means that because I don't have any carry, I can say that my subtraction numbers is minus. Okay. Uh, what will happen if I have the flute number? It's also again same, and we have the two's complement of subtracted number. And if I have the carry number, I should just drop the carry. Okay. If I want to use the addition with the help of two's complement things, we have done this last time, but let us again do it. This also same. We can take the two's complement of addition number and check the numbers. Suppose consider the 8 bits of two's complement binary and numbers that I shows here. The first number is minus 88, which will be add to 122, and I'm sure we know that the result is 34. Okay, if you do this job also with the help of two's complement binary, you can uh, get the answer. See, suppose I elaborated more here. 58 I show here, and minus 40 I show here. Then if you do the addition, this minus will specify by the first digit that I put here. This one will show me the minus number. And you will see that the addition of these two number will become 18. Okay. Um, then let us see what will the carries if we carries with overflow. What is the difference between them, and uh, what could be the main definition between these two? We can say that if A and B are positive sign, then we don't have any overflow. If A and B are the same sign, but the result is opposite sign, then overflow has occurred, and the answer is therefore incorrect. Overflow occurs if the carry into the sign bits differs from the carry out of the sign bit. Okay, and if again we want to consider the 8 bits of some arithmetic job between number A and B, which I mentioned here for you, means that the number for 40, I want to add it with 58. I know that the result is 98. Simply, you will see that the uh, result is something like this. And the minus 88 and 122, which result is 34. Uh, Here I show. I have two assignments for you that I want that you do it and send it for me. I specify it here in this part of the PPT. And you should do, along with this assignment, I want that all of you, again, solve all the example that I have in this PPT. It's very important for us. I bring this reference from here, and I wish that today you learn something regarding this arithmetic job. Then don't forget this assignment. I will put it inside of the mock system also. It's assignment number 4. And also I will put in the our group lectures in the WeChat. Just right now, I have done that. You can check. Um, please take and also see the videos. And if you had any problems, please inform me.